Good morning, everybody. Good afternoon for the ones that are in Europe. I am Francesco, CEO and founder of Qualysense. And today I'd like to introduce you to the QSorter technology. So maybe for those that don't know us, so we are specialists in high-speed single kernel technology. So we have developed in the course of the last years a bunch of solutions for the seed industry that are able to detect quality in different dimensions, most importantly in the field of purity on every single seed, and to sort accordingly. So this is what we stand for, and I would like maybe to give you a little bit of insights into the business. So next slide, please. So the company was actually founded in 2010 by myself and another colleague. So we both experienced in sensing technologies, and in particular, we were working on satellite missions to detect natural parameters in agriculture, crop, canopy, water, and different types of targets. And we came up with the idea of applying similar technologies to the ground and not to the space, to really try bringing like a sensitive innovation into the business of agriculture and food. And as of today, so we have about 40 people. We mostly work between Western Europe and the United States. And we have developed a couple of platforms that I will introduce you in a second. Maybe next slide, please. So as of today, I am very happy to say that we are cooperating and collaborating with many leaders of the seed industry and food industry to really advance quality in seed breeding and production by tackling some of the critical hurdle of the industry. Next slide, please. So maybe when we look at the seed value chain, we all know about how much value are we talking about. Probably for all of you that are sitting in this call, it goes without saying that the value of one seed is much higher than the value of one grain of the same crop environment. And just to give an example to set a sort of a benchmark. So if we look at corn, we're possibly talking about $300 per metric ton whenever we buy grains for maybe ethanol or for food production, while we talk maybe about 30 to 50 times more value per metric unit when we look at the seeds. So therefore, it is of customer importance to define what quality are we dealing with and spots where the problems are. Next slide, please. So when we, examine a little bit through the magnifying lens, the seed production chain, we can definitely realize that there are a number of problems that are happening along the process. So starting from the breeding, we go into multiplication and then into production itself. So all in all, we estimated, and these are numbers that actually are provided by our customers, that about maybe up to 10% of the seeds are lost because of purity issues. And when we look at purity, we probably talk about three dimensions. So one of them is the genetic purity, one of them is the germination rate, and last but not least, there are the physical purity issues related to either field contaminations or maybe cross-contaminations during storage, during processing, and so on. Now, most importantly is yeah, of course there is a lot of economical value in there, but it's also true that at the same time we are wasting arable land and producing a lot of CO2 for nothing. I always like to bring up the example of the corn again, and so whenever you waste 1 metric ton of corn, you're actually wasting one entire soccer field of land that could have been dedicated to maybe food production, for example, and you are emitting a lot of CO2 equivalent to possibly the one produced by 3 cars making the round of the world for about an entire year. Now, the good news is that in a way, in this discarded fractions, which we said they amount to up to 10%, a very good half of it is actually good seeds. And then the question is like, how can you recover these seeds? And this is where we definitely are focusing. So we are offering our customers the possibility of, first of all, understanding the entity of the problem when it comes to the purity. And on the second side, thanks to our production scale platform, we can in fact sort entire lots and recover whatever of good is left into the basket. There are obviously so many details about the logistics and when are you able to recover, if it's before coating or after coating, maybe after packaging, but these are all aspects we could go maybe later through maybe the Q&A. Can you jump a couple of slides forward, please? Slide number 7. Yeah, one more. Yeah. So maybe a little bit of info about the technology. So in these slides, you see a couple of platforms. Actually, the one that is a bit shaded on the right, it's a laboratory platform, which we call QSorter Explorer. And this is really aiming at helping people understanding what quality is in the purity dimensions. So you throw in a lot, every seed is analyzed, and a certain amount of parameters is then defined afterwards. While the one on the left is our new baby, and we just installed the first unit a couple of months ago in the United States, and it's a production scale unit. And so if you have a lot of several metric tons, you could actually dump it into this device, and the device can sort it according to your quality and purity parameters. Next slide, please. So why is the QSorter Qualysense unique? Well, as of today, we still can claim that this is the only technology able that combines in just one spot, first of all, different type of sensing equipment. In particular, we can measure with high resolution spectrometer inside every kernel. And detecting therefore some light back that would then be proportional to some of the nutritional or compositional elements of the grain, of the kernel. And on the other side, we can even detect from the outside with camera technology, shape, size, any morphological aspect. So this is one specific element that we bring that is pretty unique. On the other side, it's also true that we do assess, as I said earlier, every individual grain. So thanks to vacuum technology, we can in fact block or lock every kernel in one position and bring it in front of the measurement area. This is very, very important because other measuring technologies out there, they rely maybe on chute systems or belt systems. And the fact that the grain or the kernel is not constrained to a transport mean doesn't allow really a precise measurements of certain parameters, especially the compositional one, which are the key parameters you really want to understand. So now, once you have these two data sets of data, so the spectrum and the 3D image, you can then apply a certain set of algorithms in the field of neural network, machine learning, deep learning, regression, and extract a bunch of quality parameters. So it's like you have a Facebook profile for every kernel in your sample or in your lot. Now, what is the output of that? Well, on one side is a digital output, so you have a huge collection of data points, which could turn out to be very useful in a number of applications. But on the other side, you can actually sort physically into A, B, C. And in fact, we also innovate a little bit there because we can offer more more than 2 sorts. So with our small device, we go up to 3 sorts. With the big one, we could go up to 5 sorts in just one pass. So you could combine, I know if you are looking at a corn kernel, you could say, I would like to have the kernels that have this type of germination and maybe this type of size in the same basket, and combine then, for more classes, other type of criteria and parameters. In the next slide, we observe a screenshot of the transport mean, which differs a little bit. So in the laboratory unit, the QSorter Explorer, we do have a belt. Under the belt, there is low pressure applied, and there are little perforations on this belt where every seed is actually locked in and transported throughout the whole process, so sensing, data extraction, sorting. While in the big device that can sort up to 3,000 kernels per second, we have the same concept, but applied to a drum, which inside has, again, low pressure to constrain the grain on its outer surface. I would like to show you now a very short video. So if you guys could actually send that video live. Let's see if we start. Yeah. Unit, footprint. So these are grains going also very fast and analyzed. Yeah, these are the screenshots with the multiple sorts. And this is the first installation in the US into a sweet corn production facility, where we have helped the customer making sure that the lots were GMO free. So in particular, they were not bearing contamination from field corn. But other than that, we did also look at pre-germinated kernels and broken kernels and sorted accordingly. All right. So in this little video, you have seen a little bit the two platforms, so the small ones and the big one. The small one has a laboratory side, so you can place it over a table. And as I said, it's very easy to use and to integrate into your quality flow or into your breeding flow. And the big one is definitely bigger than that. So we're talking about 2 meters tall for a 1.5 meters, width and a length footprint. And I think in the last part of the video, you have seen our first installation into the States, where we have helped a sweet corn customer to remove field corn contamination, so GMO contamination. But we also help them increase in germination by removing all the pre-germinated kernels and the broken kernels. I also like to mention about these applications that most of the job was done with the near-infrared spectrometer, and it's not that obvious that with camera technology you could actually detect all these details at a very high precision. in this slide, you have a little bit of a flavor of what the QSorter technology can do. So if we start from the top left, you can obviously go into the physical parameters, and there, it's also interesting to see which accuracy we can bring compared to maybe scanners or other things in there that today help you in this direction. We go into the effects of different types, as I mentioned earlier, broken, but could be also some discolorations and so on. That could be very useful, for instance, if you want to clean production culls and recover the seeds that you have in there. But the most interesting parts are coming on the right. So first of all, it's on the compositional side, and I'm just listing here some of the usual properties you could go for, oil, moisture. But it's also true that we did develop projects with predictions of more complex things, such as maybe fatty acids and some type of protein. But but not least, when you go for production scale, I think people are probably shocked or scared of too much data. So the goal is always to really transform all the information that you detect on a per kernel level into maybe one meaningful parameter that the plant can handle. And in that specific cases, we definitely look into purity and germination. And we have several projects in this direction that demonstrate how the QSorter can in fact help seed companies optimize in here. Maybe just to go next slide, please, a second. So just for understanding, I think one of the key underlying assumptions that enables all this type of innovation is really the single kernel distribution. So as of today, probably 99% of the technologies out there are helping you define like an average content, right? But the QSorter can in fact tell you also what happens around that average content. Now, I bring up a very simple example with moisture, but we look at some customers sometimes that they had maybe identical average of moisture in two different lots, but then distributions were completely different. And then the question is like, okay, how do I handle these two? Do I store them differently? Do I dry them differently? Now, with moisture, the example is quite straightforward, but the same could be applied to any other parameter out there. Maybe I like to switch to slide number 15, if possible. Still another couple. Yeah, this one, please. Yeah. So maybe we come now to the final, like how people are using our technology. So obviously, when it comes to breeding, you have the possibility of screening up to 30 seeds per second with respect to multiple parameters in just one go. And this is obviously one of the reasons why people buy and use our technology. So in a non-destructive and non-invasive way, you can in fact select the seeds that you really need to bring forward into your program and optimize a number of aspects. So first of all, your statistical confidence increases enormously because thanks to this speed, you have a lot of data to base your judgment on and your conclusions on when choosing on what to do with a specific family, variety, or trait and propagate it into the next generation. You can definitely optimize your field trials by having more dedicated plots to maybe more complex type of selections. And last but not least, as I said earlier, a lot of data is produced, and this allows you to also build, I would say, historicals that you can query over time and observe how populations are changing on a year-to-year basis. So as of today, we have customers for this specific applications in the field of soy, corn, wheat, barley, rice, peanuts, and I would be glad, to tell you about it maybe later through the Q&A. Then on the other side, if we move to the next slide, we talk more about production. And here, as I said earlier, the big technology or the big platform is really the game changer, because yeah, it's nice to have the data, but then what do you do with this data? And the answer is coming through the horizon. So whenever there are some challenges with purity, you can then dump the entire pro box or bag into the horizon, and the horizon will be sorting that for you. So what are the maybe areas in which we are working today? So we have very exciting projects in the field of genetic purity. Now, maybe before you guys ask, so definitely we are not able to detect the DNA of the seed, but if the DNA, let's say, engineering has an impact on the phenotyping, on the compositional aspects of the kernel, we can definitely detect that. And so far, we have seen many cases where this is actually true, and therefore our sensor can pick these differences and sorting accordingly. We are working with a number of tollers as well in optimize in culls or discards that are produced during production by gravity tables, by color sorters, by any other type of technology. And this is also very, I would say, very interesting project, because it offers customers the possibility of gaining already today by starting, sorting in a dedicated fashion certain lots that suffer from this problem. And last but not least, we're also looking at germination, and we have also there projects in the field of corn, some vegetable seeds that we are collecting data for, and we are observing also good results coming up. So as I said earlier, purity is the key word. While with the small technology we help understanding about purity, with the big technology we help recovering seeds that suffer from purity issues. I come to my last slide, the next one, please. So this is just an overview of our portfolio as of today of crops and applications. And there is definitely a lot to be done, but at the moment, I think we have quite some focus on the oil crops to start with, in particular, I would say corn and soybeans. We also are looking at sunflower and the canola. These are next on our pipelines. In addition to this, we also work with a bunch of other commodities that have probably a strong impact, maybe in the food industry more than on the seed industry. So other than that, I think I will be then happy to take some questions. So please feel free to write them in the live chat. In the meanwhile, I could maybe answer some of the questions that we received before the seminar. In particular, somebody asked about the purity of the accepted fraction. Well, the answer there is that it depends on the applications that we are looking after. And when we talk about purity, there is somehow a trend number that goes around 95%. And that is at least the minimum that you should try to achieve when sorting with the purpose of increasing purity. So 95%, I think is generally true for maybe germination. If it's about purity in terms of genetics, there is obviously a difference whether you target the parent seeds or the production seeds. So the production of the parent seeds has definitely higher requirements in terms of purity than the offsprings. And if you talk about purity, then physical purity, we probably also traveling in the range of 95% there. I think a follow-up question was about the reject. So how much good product you should throw along with the bad product in order to ensure that the good fraction meets your purity requirements. And there, it depends a bit on projects, but we generally travel between the 1 to the 3% amount of reject. And I have to say that this is a very good performance if you compare to any other sorting technology out there. again, please feel free to write down questions. I'm going through the list of existing questions as I speak. Somebody is asking about germination results, if you're able to predict it or not. So far, we've been working on two different, I think, pipelines for germination. So one of them, as I mentioned earlier, is about maybe looking at a lot and removing whatever is not uniform. And that comes in different shapes. So there were maybe broken seeds, there were very small seeds, there were seeds that had a pre-germ, not always detectable with the naked eye because it's just about to, emerge under the outer surface of the grain. And there we have observed like a range of germination increase from 5% to 20%. So that result was really amazing because some lots for the customers were really unusable and therefore with zero value in terms of dollars. And after that sorting, the recovery rate and the value recovery rate was super high. So this is one approach. So you try to really get rid of whatever is non-uniform and see what happens to the last lot. On the other side, we have projects where we are looking at the capability of detecting whether something germinates or not. And so far, we've been working on corn. We did some tests on fennel seeds, on artichoke seeds, so a couple of vegetable seeds. And we can definitely say that the technology is able to say with 85 to 90% accuracy what is the like a possibility of having a plant afterwards. The next level for us is more understanding about the quality of this plant, so more in terms of vigor, what we can predict beforehand. But obviously, this could be really like a great game changer for the industry. Oh, in the meanwhile, one question arrived. Somebody is asking about the pricing of the lab sites unit. So projects are very custom in a way because we have to deal with certain germplasm that are not definitely unique. So there is a certain level of personalization that we should go for. And but to give you a ballpark figure, we're probably traveling around the $150,000 for one unit. And at the moment, we also, activating a sort of a subscription model where maybe we lower the initial payment amount, so for people to, get more familiar with the technology, and then maybe agree on a 5 years subscription that gives you access to a certain amount of services and licenses to algorithms. So that's a little bit the price range of the small unit. Generally, in the projects that we see, I think one of the critical parameters is always the amount of samples. Obviously, the larger the amount of samples you deal with, the faster is the return on investment. But generally, we see like ROI in the range of, I would say, between 2 and 3 years. That's what we observe in the seed industry. There was another question about algorithms. I think I quickly touched base before by saying that we use a large spectrum of algorithms, and there we never try to make things complex if it's not necessary. So we usually look at every problem in an independent way and try to solve it in the easiest way. But sometimes things can get very complex, and when we go to maybe deep learning, machine learning, that's obviously maybe that is bringing more sophistication. But on the other side, that kind of approaches also offer certain advantages because the device can actually learn over time and improve the robustness of the algorithm. So this, I think, it's something to really, exploit maybe over a certain amount of seasons and data that you have collected into the database. Somebody's asking whether we have a presence in United States, and honestly, we do possibly about 80% of our business in the States. So yes, we are present, and we are currently, ramping up offices in Iowa and the Midwest to be more closer to our customers. We also partnering with a company that has quite a few technicians available in the field. So especially in the case of the production scale unit, that's, I think, very, very important. And maybe one aspect that we are also pushing a little bit more forward is the sorting services. So in some cases, probably the cost of the technology, especially the large scale unit, is a bit prohibitive if you don't have certain volumes to sort. So what we are starting to offer are services. So if you have anywhere some trouble with purity and you would like us to maybe look at that problem and sort your lots, we can definitely arrange that. And we have at this point 2 locations that we could go for. So one is in Illinois, that's for US, and one is in Switzerland for Europe. So please feel free to contact us, and we could talk about that more in detail. Any questions? All right, so I think we are done with the session. So I thank all the people that have joined us today for this webinar. Maybe I just like to mention that you can, contact us through LinkedIn or simply writing an email to info@qualysense.com. And address any questions you would like us to answer. I also like to tell you that we can organize live demos for you. So we have a specific setup with cameras, and we can guide you through the various platforms. And last but not least, we also could arrange some try and buy, so you could use the technology and test the platforms for maybe a month or a few weeks. And then if certain requirements are met, we can, transform that trial into a purchase. Again, think about all the inputs that I've been sharing with you guys. I understand that maybe not all of you know us, so please take the time to get in touch. And once more, I thank you for this opportunity. I would like to thank you, the ISF, for such a chance, and looking forward to meet and to talk with many of you in the next days or months. Thank you, everybody. I wish you a very great day.